Analysis of variance is the tip of a very large iceberg, all aimed at how to design and analyze experiments to come up with statistically valid results or interpretations. Right, you can make your own joke about whether or not we're on the Titanic or not. Let's hope that we're not, right? Okay, so one of the typical kinds of scenarios that you're going to face in an engineering kind of context is that we have a particular specific response that we're interested in, but we have different ways to get there, and we're trying to decide which way is the most effective way. The scenario I have written here in text up above is the notion that we have different curing methods for concrete. We'd like to select which one is going to be the best for our specific application. And so you see fogging, barrier, and heat. Fogging is a lot like these sort of misting machines that you see on the sides of sporting events, or you see them sometimes down in the south, in the west, where you've got real hot weather. You got little mister sprayers kind of thing. Barrier is like a plastic barrier, and heat is, of course, a device to maintain heat. The whole point here of curing is to provide sufficient heat and humidity so that early age concrete can continue to develop strength. So that suggests right away to us the response quantity that's of interest. And that is that we have a single factor of interest, and that is selecting a curing method. And then we have, and that is a key aspect here of what we're going to do, single factor experiments. Right? And we have three different levels of the factor, and sometimes this is called a treatment as opposed to a level, and you'll see that come back to us in a variety of cases. Right? And the response quantity of interest is the compression strength. Right? And what's going to happen is that ANOVA is basically, analysis of variance, is a technique for testing the hypothesis that the mean of these three different levels or three different treatments are the same. But what we actually do is we look at variation to really come back to this hypothesis. Right, so several more examples, and note the pattern that we have at work here. The factor, for instance, in this next example, is which vehicle to buy. And we've got 4 different brands. Let's say that our most important criteria is fuel efficiency. So there's single vehicle we're going to purchase. There's our levels 1 through 4, and taking a look at fuel efficiency. From a more practical standpoint in terms of engineering, let's say that we're designing a GPS satellite something like a surveying instrument that is GPS connected, and we need to decide what the data collection time ought to be, the access to the satellite for the information. Should that be 30, 60, 180, or 300 seconds? Notice a half minute all the way up to about 5 minutes. Right? And so obviously we want this to happen as fast as possible. You would presume, though, that the longer you collect information, collect data, that the more accurate, more precise your resulting measurement will be. But is that really true? Do we get any increase from, say, 180 to 300, or where would that breakpoint be? So the response variable that we might use is the error between the true north and measured north as a way to take a look at these different levels. Right? Another one might be, and this is one that we're actually going to use numerically in a later example, is the mechanical property. It'll turn out to be bending stiffness associated with 3 different lumber grades of a specific species. And so the way we're going to differentiate between those is to take a look at the mean modulus of elasticity. Or then finally, maybe we're looking at different heat treatment processes related to the single factor of steel hardness, and we're going to use the mean Rockwell hardness or some other standardized method of doing hardness to differentiate between those different heat treatments. Right? The big picture goal here is to ask and answer the question, do the different levels, as the treatments, produce the same or different responses? And part of this goal of answering this question, it's helpful to think about the response as being the dependent variable that we're after, and the levels are the independent variables. We're trying to keep everything else, of course, the same, and only vary one thing in this single factor experiment. Right now, again, I'll go back and say that the ANOVA is used to test the hypothesis about the means of these different populations, these different treatments, right? And although that's what we're doing, the big picture, or maybe the little picture, depending on which way you want to look at this, is that we're actually going to go look at variation in order to come to these kinds of conclusions about the means.